Chapter 6. Chapter 6 is about polynomials. In this chapter, we are going to take what we learned in Chapter 5 about quadratics, and we're going to expand it to polynomials in general. So a lot of what we learned about in Chapter 5 is going to be applicable in Chapter 6, which is what makes this chapter so hard. It is a direct extension of what we just did. The first section is not particularly difficult. It's a very much of an introduction. It's about just polynomials in general. We'll have some definitions, a little bit of actual math, and then a look into what we'll be looking at later on in the chapter. So, our learning targets for today: I can identify, evaluate, add, and subtract polynomials. And then I can classify and graph polynomials. Now with this graphing, we're not going to be graphing like we're graphing quadratics quite yet. It's just going to be glancing at what the graph looks like, using a graphing calculator, describing it, things like that. We'll get into actually graphing these polynomials in a later section. So, first thing we have, before we start talking about polynomials, these big words, what is a monomial? So another big word. Well, a monomial is really just a bunch of stuff multiplied together. That's all it is. No, that's not the official definition you'll find in the book, but when you translate it to English, that's what it means. So what are some examples of monomials? 3x, negative 5a to the fourth. 4. Yeah, 4 is just a monomial. 2x squared y z to the fourth. And 4/3 pi m to the seventh n cubed. Those are all monomials. It's all just a bunch of stuff multiplied together. There's no addition or subtraction, anything like that. It's all just multiplication. That's what makes it a monomial. So, if a monomial is a bunch of stuff multiplied together, what's a polynomial going to be? Well, a polynomial is just the sum of several monomials. Several could mean 2, it could mean 3, it could mean 50, it could just be 1. A monomial is a polynomial. It's just a special case that we start with. So what are some examples of polynomials? 3x plus 4. Negative 5a to the fourth plus 2x squared y z to the fourth minus 6x plus 1. That's a monomial. That's an ugly monomial. We won't get all that many of those once we get into the chapter. Today you'll have some, because today we're just kind of playing around with them. But that one is definitely uglier than what we'll be dealing with, typically speaking. A cubed 3a squared b plus 3ab squared plus b cubed is a monomial. That one, yeah, we might see stuff like that off and on in the chapter, but that's more of a formula. In fact, this is the equation if we multiplied out a plus b quantity cubed. That's what we'd end up with. And then a more typical type of polynomial we'll see is something like x to the fourth plus 2x cubed minus 3x squared plus x minus 5, where we have only x as a variable, some coefficients in there, we have exponents, but not a lot of stuff like we saw with the a's and the xyz's, things like that. That we're not going to see too much after today. So that's what a monomial is and what a polynomial is. We're going to be looking at different pieces of these. The first thing is the degree. What is the degree of a monomial? The degree of a monomial is the number of variables in the monomial. So we could have something like 3x. How many variables are there? Just one, the x. It's the only variable. So the degree is 1. We could have something like the purple one, 4/3 pi m to the seventh n cubed. How many variables are there? Some people say 2, some people say 3. If you're saying 3, remember that pi is not a variable. Pi is just a number. And if you're saying 2, well, couldn't this be rewritten as this? M to the seventh means we have 7 m's multiplied together. N cubed means we have 3 n's multiplied together. So how many variables do we really have there? Well, if we count them all out, which is really difficult with m's and n's, we can find that we have 10. Sorry, not 7. We have 10. The degree is 10. So instead of having to multiply all that out and write all that out every time, how else could we possibly find the degree of a monomial? Well, 10, we had 7 m's and 3 n's. We could probably just add these two numbers together. And that is the case. You can add together the exponents of the variables to find the degree. There are a couple things to watch out for here that we're going to see in the next minute or so. The first one, this isn't something to watch out for. This is just an easy example. Negative 5a to the fourth. How many variables do we have? 4, because there's 4 a's, so the degree equals 4. But how about 5a to the fourth b squared? How many variables? Well, we have 4 of those and 2 of those. Add them together to get 6. How about 4? How many variables do we have in 4? Well, there's no variables. 4 is a constant. So the degree there is just 0. Well, what if we said 4 cubed? Well, people say, hey, it's 3 because there's 3 and it's an exponent. But it's still just a number. 4 cubed is 64. There's no exponent there once we actually multiply it out. There's no variable. And remember, the original definition is the number of variables in the monomial. So 4 cubed is still 0. So the exponents on numbers will get people. The other one that gets people is something like this. 2x squared y z to the fourth. How many variables do we have? People are like, all right, so 2 plus 4 is 6. True, 2 plus 4 is 6. We have 2 x's, 4 z's, but we also have a y. Remember, that's y to the first. So this is 2 plus 1 plus 4, which gives us 7. So 7 is the degree. So the two things to really watch out for are going to be the exponents on constants and the variables that only have 1 for an exponent. They tend to get overlooked. Also, making sure you remember pi is not actually a variable. And notice it doesn't matter that we have fractions, we have negatives, none of that matters. So, this is the degree of a monomial. Why don't you try a couple? This should really only take a couple seconds. So find the degrees of monomials. We have x to the 8th for one problem, and we have m cubed n squared p for the second problem. It's very possible that by now you have already found the degree, but if not, go ahead, pause it for a second and find it and then come back. Alright, how was that? Well, x to the 8th, it's a pretty easy one. Degree equals 8. And then m cubed n squared p, we have 3 plus 2 plus 1 gives us a degree of 6. Pretty easy, as long as you miss those couple obstacles. Alright, well, that's monomials. Let's look over at the degree of some polynomials. How do we find the degree of a polynomial? Well, it's actually basically the same as finding the degree of a monomial. We then just have one extra step, and that is figure out which one is biggest. The degree of a polynomial is the largest monomial degree in the polynomial. So we're going to find the degree of each of the monomials, each of the terms of the polynomial, and then we just have to play the what number is bigger game. So if we start out with 3x plus 4, well, 3x has a degree of 1, and 4 has a degree of 0. What's bigger, 1 or 0? Sure enough, 1 is bigger. If we go to the next one, 5a to the fourth plus 2x squared y z to the fourth minus 6x plus 1, we can find the degrees. 5a to the fourth, it's going to be 4. The next one, we have 7. We found that over on the other side. And then minus 6x has a degree of 1, and 1 has a degree of 0. Which one of these is biggest? 7 is biggest. The degree equals 7. Do you think you might be able to guess what the most common mistake of find the degree of a polynomial is? Do you have a guess yet? If your guess was people add all of these numbers together to get the degree equals 12, then your guess would be right. Don't add the degrees of the monomials together. Just use the biggest one. What if we have something like the a cubed 3a squared b one? Well, let's see. A cubed, that's degree of 3. 3a squared b is degree of 3. 3ab squared, degree of 3. b cubed, degree of 3. Well, which one's biggest? Well, they're all the same. The degree is 3. That's not going to be very common when you have to find the degree. You're not going to see things like that too much. But if it comes out that they're doubled, it's just use whatever the biggest number is. The biggest number is 3. It happens more than once. Oh well. And then for the more typical type of problem, x to the fourth plus 2x cubed minus 3x squared plus x minus 5, this is really easy. We can just look at the exponents. What's the biggest exponent? 4 is the biggest exponent, so the degree is 4. So those are finding the degrees of the monomials and the polynomials. The hardest part isn't finding the degree. The hardest part is remembering what to do when you're asked to find a degree. It's kind of like it's a vocab type question. So let's move on to some other stuff. Polynomials. Standard form. What is standard form of a polynomial? In standard form of a polynomial, we're going to order the different terms, the different monomials, by their degree. We want the highest degree first, and then the lowest degree second, or last. So, if we have something like this one that we just looked at, well, the 7 is higher than the 4, so it should go the 7th degree, then the 4th degree, then the 1st degree, and then the constant at the very end. So to put it in standard form, we just need to switch these two. And there we have it in standard form. Again, this isn't like one that you'll be dealing with most of the time with all the weird variables. Well, putting them in order is pretty easy, so let's look at some of the kind of weirder ones. What about this one where the degrees are all 3? Well, if the degrees are all 3, if the degrees are all the same, pick one of your variables and just put it in descending. Notice here we have a cubed, and then a squared, and then a, and then no a. And what that does is it makes the b's go up. You're not going to get, like, I'm not going to throw a trick problem at you where you have to do something like this and put it in standard form, but that way looks better than having a cubed plus b cubed plus 3a squared b plus 3ab squared. It's just a better order. And then what about the kind of normal polynomial? It's already in standard form. We just start with the biggest exponent, work our way down, which again looks a lot better than if we just had the terms kind of randomly scattered throughout. We have x squared plus x cubed plus x to the fourth plus -5 plus x or minus x. That's just that's out of order, and it feels wrong. Put it in order, just start with the highest degree, work your way down. The leading coefficient. That's another vocab word. What is the leading coefficient? The leading coefficient is the number in front of the highest degree monomial. And coefficient is the number in front. That's what they're called. They're called coefficients. So in this blue one, -5 is a coefficient, 2 is a coefficient, -6 is a coefficient, and 1 is a coefficient. The leading coefficient is the one in front of the largest degree, which would be 2 in this case. Once we put it in standard form, it's the very first thing, because the highest degree monomial will be in the front, and then it's the number in front of that, so it's the very, very first thing. So, in this one, it's the 2. In this one, we don't really talk about leading coefficients. That's okay. Down here, well, what number is in front there? We're looking for that number. How many x to the fourth do we have? We have 1 x to the fourth. So the leading coefficient would just be 1. The next vocab word is the number of terms. Well, the terms are just the monomials. How many monomials do we have? So this blue one, we have 1, 2, 3, 4 terms. The green one also has 4 terms. The red one has 5 terms because there's 5 monomials added together. How about this one right here? We have 6x minus 4x to the 4th plus 5 to the 7th. Let's figure out the degree, put it in standard form, find the leading coefficient, and figure out how many terms it has. So the degree, that's going to be the highest monomial degree. Well, let's see, 6x is 1, 4x to the 4th is 4, and 5 to the 7th is not 7. It's 0 because this doesn't have any variables. So the highest is 4. Put it in standard form. We want to move this one to the 4x to the 4th to the front. Notice the negative comes with it, plus 6x plus 5 to the 7th. If you really want to, you can figure out what 5 to the 7th is. It's going to be a big number. You can just leave it as 5 to the 7th. What's the leading coefficient? Well, negative 4. And how many terms do we have? 1, 2, 3. So 3 terms. So why don't you try these? We have 3x cubed plus 2x to the 6th minus 4x to the 4th minus 1. Find the degree, standard form, leading coefficient, number of terms. And then do the same thing with 4x cubed plus 2x to the 4th plus 3 minus 7x plus x squared. Find all of those same things. Notice that there's not really any math involved in this, so it shouldn't take very long, but it's just definitions. So go ahead, pause it, figure this out, and then push play again when you're ready. Alright, let's look at the first one. The degree, which one's biggest? Well, x is 6, so the degree is 6. Standard form, we need the 2x to the 6th first, then the minus 4x to the 4th, then the plus 3x squared, x cubed, and then the minus 1. Leading coefficient is that 2. And the number of terms, we have 1, 2, 3, 4 terms. Did you get that one right? Do you need to change anything? If you need to, pause it and change what you think you might need to change on the second one. If you got them right, which I'm assuming is most people, but you never know, just keep on going. So this last one, the degree, well, the biggest exponent is 4, so the degree is 4. Standard form, need to put them in order. The x to the 4th and the x cubed, x squared, x, then 3. Notice the minus follows the 7x. Leading coefficient, it's that first number, 2 again. And number of terms, in this case we have 5 terms. So, those are most of the vocab words for this chapter. The vocab can be kind of confusing because you either remember it or you don't, and that's a tough one. Next thing, we're going to classify polynomials, and classifying polynomials is just a fancy word for naming them. When we name polynomials, we're going to give them 2 names. They're going to have a first name and a last name. It's kind of like my bologna. My bologna has 2 names, a first name and a last name. The first name is going to be based off of the degree of the polynomial, and the last name is going to be based off of the number of terms in the polynomial. So each of those are numbers, so we have a few numbers coming down. If the degree is 0, what does the degree of 0 look like? Just a number, like 7. What do we call something like 7, just a number? We call it a constant. So if the degree is 0, it's called a constant. If the degree is 1, we need just one variable, something like 2x. Well, what is 2x? If we graphed 2x, it would look like a line. That would be a linear function. If the degree is 2, that would have 2 variables. Could be like a, b, but most likely it's going to be like x squared. Well, what does x squared look like? That was what we just dealt with last chapter. That's a quadratic. If it has 3, we're going to get something like x cubed. That's called a cubic, right? X cubed, cubic. 4, x to the 4th, is called a quartic. Quart is the root word for 4, like quarter. There's 4 of them in a dollar. Quart, there's 4 of them in a gallon. To the x to the 5th is going to be a quintic. X to the 6th is going to be a sextic. 7th is going to be a septic. 8th is an octic. 9 is a nonic. 10 is a decic or a decic. They have names as high as you want to go, but after a certain point, nobody cares. Nobody actually knows what they are, and so we just call them 6th degree, 7th degree, 8th degree, 9th degree, 10th degree. If you had x to the 57, it would be a 57th degree. I don't know the name for that one. 12 is a dodecic. And so after 5, the names get really boring, but really easy to remember. So let's go over the number of terms. If we have 0 terms, we have nothing. If we have 1 term, we have a monomial, right? It's just that special case of polynomial where there's only 1 term. If we have 2 terms, a root word for 2 is bi. It's a binomial. 3 is a trinomial. 4, quadrinomial, which is really confusing because 2nd degree is a quadratic. 5 is with 5 terms, and with 6 terms, and with 7 terms, and with 8 terms, and with 9 terms, and with 10 terms, etc., etc. Again, there's names for them, but nobody actually cares. So, if we wanted to name a couple, x to the 4th minus 3x. First, we look at the degree. It's x to the 4th. That's 4 degrees, so that's a quartic. And there's 2 terms. Binomial. It's a quartic binomial. 2x cubed plus 5x minus 2. Let's see, it's a degree 3. So that would be cubic, 3 terms. Trinomial. So you have a cubic trinomial. How about 2x plus 3? Try that one real quick. I'm not even going to let you pause it this time. So 2x plus 3, that's the degree of 1. There's 2 terms, so it's a binomial. So a linear binomial. When we factor our quadratics, just like we're going to factor the cubics and quartics and all these polynomials, we're trying to factor them into linear binomials. X plus 5, 2x plus 3, things like that. Adding and subtracting polynomials. This is actually really easy. You've been doing it for years. We did it in chapter 1, remarkably enough. We were adding and subtracting quadratics last chapter. Basically, to add and subtract a polynomial, you're just going to combine like terms. That's all that's going to happen. So if we have something like x cubed plus 5x squared minus 2 plus 3x to the 4th plus 2x squared minus x plus 6, we just look for like terms. We have some x to the 4ths, we have some x cubed, some x squareds, some x's and some constants. So our like terms kind of match up like that, and just combine them. Let's see, we have just that 3x to the 4th. There's no other x to the 4th, so there's nothing to add it to. Same thing with the x cubed, there's nothing to add it to. We have 5x squared and 2x squared. We can add those together to get 7x squared minus x, and then negative 2 plus 6 is just plus 4. So we just combine our like terms. Notice what we did not do is we did not change any exponents. That's the biggest mistake people make. They say, oh, 2x plus 4x is 6x, but x cubed plus x to the 4th is x to the 7th. It is not. X cubed plus x to the 4th is x cubed plus x to the 4th. You can't add them together. Notice when we added the x squareds, it didn't all of a sudden magically become an x to the 4th. We have 5x squareds plus 2x squareds gives us 7x squareds. And that's all there is to it. That would be the answer. Notice I put it in standard form. It's actually easier to add when you put it in standard form because you can look for how many x to the 4ths do I have? How many x cubes do I have? And just straight down the line. How about subtraction? The first thing to do with subtraction, distribute that negative. it needs to go to each of these things. It just changes all the signs. Now it's an addition problem. We have x cubed, we have x squared, we have a few x's, and we have a couple constants. So we can add those together. Well, negative x cubed plus x squared looks negative 3x, plus another negative 3x is negative 6x, and then 4 plus 4 is plus 8. And there's our answer. That's our polynomial that we got when we added them together, subtracted them. So it's just combining like terms. Again, you guys have been doing this for years, so go ahead and try these two real quick. We have an addition problem, 2x squared plus 4x plus 4, plus x squared minus 3x plus 2, and a subtraction problem, x cubed minus 4x plus 7, minus the quantity 2x cubed minus 4x plus 8. So go ahead and pause this, add or subtract, and then come back when you're done. Alright, so first one, just combine the like terms. You get 3x squared plus x plus 6. And the second one, first distribute the negative, and then combine your like terms. X cubed minus 2x cubed is just negative x cubed. Negative 4x plus 4x goes away, it's 0. And then 7 minus 8 is negative 1. So we have negative x cubed minus 1. So, how do you feel about adding and subtracting polynomials? I have one last topic here, and that'll be describing the shape of polynomials. To describe the shape, we're going to be graphing these and learning a lot about them in the next few sections. Right now, we're just kind of exploring what the shapes are. So to describe the shape, we're going to graph it using a calculator or other form of technology. Describe the shape of the polynomial. A sketch might help you describe the shape. And then identify the number of zeros, the number of roots. So if we start out with f of x equals x cubed minus x, we can graph it using a graphing calculator. You just plug it into our y equals, and we graph it, and our graph looks like this. And so what does the shape look like? Well, some people always try and describe, oh, it looks like a tree, it looks like a branch, it looks like... No. It goes up, then it goes down, then it goes up again. That's really all you need to describe when you're looking at the shape right now. A sketch can help. Your sketch doesn't have to be super accurate. I have a graph. I'm going to make a sketch using my mouse. It's not going to come out all that pretty. It's a lot easier with a pencil, but sketch looks kind of like that. It goes up, then it goes down, then it goes back up again. With a pencil, it would have been a little bit more accurate, but I'm not graphing it right here. I'm just sketching. What do I see on the graph? I'm just drawing it on paper. And then how many zeros do we have? Well, if we look, we have 1, 2, 3. So there's 3 zeros. I know if you're looking at this on a phone or something, it might be really small, so we can zoom in a little bit, or a lot, and we can see we have 3 zeros. 1, 2, and 3. And we'll be doing a lot more with those later on in the chapter. Right now, we're just looking to see how many do they have. You'll be graphing a few different polynomials and seeing how the zeros have, and we're going to be looking for patterns there. So, I will see you guys in class. Be ready for a quick group activity.